Hello, my name is Heinz Wanzenböck. I am head of the Biomedical Microsystems Lab. We are part of the Institute for Solid-State Electronics at the Faculty for Electrical Engineering. Our lab is situated in the TU Wien Nano Center, which is located in the very center of the city of Vienna. In our research group, we are developing biomedical microchips where we grow living human cells on top of that. Why is that important? Those chips with the living human cells can be used in order to study cancer invasiveness, to study tumor metastasis on a chip, can also be used to simulate the function of neurons, the wound healing of neuronal injuries. And one of our current projects is that we also investigate cardiomyocytes on a chip, grown on a chip. And one big benefit of those chips is that they also allow to make drug testing and analysis of the effect of the drugs on living human tissue on a chip. In this project, Project 24, you will develop your own microchip with a microfluidic attachment on top where you can grow myocards, cardiomyocyte organoids on top. And with the microelectrodes, you will be able to measure the electrophysiology. Why is that so important to do that? With every drug that is on the market or that is under development, every drug for every disease, it has to be checked if the drug is affecting the beating of the heart. You wouldn't like to have side effects like arrhythmia or people dying because of cardiac arrest because of your medication. So all drugs have to be tested. And your chip that you're going to develop in this project is going to be a very important device that will help to understand how drugs or drug candidates are going to interact with the human heart. So in your project 24, you will develop a chip very similar to this chip here, which will consist of microelectrodes. For doing that, you will be trained and you will fabricate microelectrodes in our clean room using optical lithography and a range of thin film deposition methods. For example, sputtering and plasma-enhanced chemical vapor deposition. And this will provide a microchip like this one here with metal electrodes which are capable of measuring the action potentials of the cardiomyocytes which are going to be on top. For the cardiomyocytes, you also need microfluidic attachments like this one here. And this will be fabricated either by PDMS, casting or 3D printing. And in a final step in the bio lab, in our cell culture lab, you will add in these compartments living human mini hearts that are beating, that you can then electrically record, and where we can make studies about the drug efficiency or drug toxicity on the chip, and this provides a valuable insight for drug development. So while administering drugs to the cardiomyocytes on the chip, and this also includes the newest research drugs that are developed now at Austrian universities, you will record the electrical activity. And this will be completed by making fluorescence imaging, by making scanning electron microscopy images of cells where you can make cross-sections with the focused ion beam and where you can have a deep insight into the cell morphology, which usually you would not have in any other lab. So benefiting from our multidisciplinary approach, we bring together the methods of microfabrication, of cell culturing and modern 3D fabrication of microfluidic devices. This project, P24, offers you the opportunity to get hands-on experimental research experience in a wide range of different methods. Your project is well defined, can be done widely independently, so you don't rely on input from others. But at the same time, it's also embedded into other projects of our Biomedical Microsystems Lab, so that you can have the support of the entire team and that you can access all the other specialists in our team to get help and to guide that project to a success. I feel personally responsible for your well-being in our group and for the success and the timely completion of your PhD thesis. And I can promise you that at the end of your PhD thesis, you will not only have finished your PhD thesis in time on a very interesting project and have learned a couple of very diverse techniques. You will also look back at the time as an enjoyable time in a very vivid, very friendly working group. And you will have invested precious years of your life to make the world to a better place by coming up with a device that can help to investigate the efficiency and the toxicity of drugs and speed up the way that drugs are reaching the market. So at this point, I just can say, welcome to the Biomedical Microsystems Lab.